Hi everyone, welcome to the University of Bristol IEFT Engineering webinar. My name's Jessica and I'm the International Recruitment Officer for Turkey here at the University of Bristol. So I'm just going to introduce two of my colleagues who are also here from the university who are joining me. So we have Dr. Andrew Harrison. Would you like to introduce yourself, Andrew? And we also have Sarah Ashman from the International Office.
Hi everyone, like Jess said, my name is Sarah and I am the International Market Manager for Turkey. While the presentation is going on, I'm going to be busy in the questions section, answering any questions you have. So if you do have any questions, feel free to pop them in the question box and I will answer them.
Great. So I'm just going to quickly give a quick overview on 2020 entry in terms of the coronavirus. I know most of you will be looking to talk about 2021 entry, but for those of you who are interested about some further information about this, our website has recently been updated with information about how September's term will look. So all of this can be found on our website. We are planning to resume studies as normal in September, implementing sort of a blended learning strategy. So many of our large-scale lectures will be held online, whereas small seminars and tutorials will be held face-to-face still, with social distancing measures in place. So in order to help you with this, we'll be accepting your final transcripts provided by your schools, even if sort of extenuating circumstances have been in place, and this means you've had to finish your studies early. So we'll be accepting deferrals from June onwards, so you can send any deferral requests for consideration to our admissions team. And then all of our pre-sessional courses this year will be online in preparation for that blended learning in September. Okay. So I'm just going to give a quick overview about Bristol before passing over to Andrew, who will talk to you about engineering at the University of Bristol. So we have a lot of sort of accolades which we're very proud of. Many of these revolve around our ranking and our research. So Andrew will go on to talk a lot about the research which we're very proud of, but we are ranked 5th in the UK for our research. So this means that all of our academics and our professors are offering world-renowned research across the university. We also have a very high level of teaching. So we were voted 9th in Europe for teaching, and this really comes from our wide variety of teaching resources which we have available. There are a lot of innovative teaching methods, from sort of lab work and seminars, tutorials, one-to-one sessions and e-learning modules that will help you through your degree. We also have very high employability rankings, so we're very targeted by top UK employers, and this was done in a study of top 100 UK employers. These employers also operate globally, so this does mean that a University of Bristol degree is worldwide recognised and will help you to find that career that will take you into the sector that you're looking for. Okay, and then just a few things about the city of Bristol. So it's a really great city to live in, but we're quite biased. But obviously these statistics on the screen reflect a lot of the great things that Bristol does have to offer. So we've been voted very highly in terms of living experience, in terms of student life, and obviously this reflects a lot of young people's opinions. So we're very liberal and forward thinking of a city, and this is explained within sort of our being voted as European Green Capital. So our sustainability is also at the forefront of everything that the university does. This is sort of supported by the arrival of Greta Thunberg in Bristol to support our climate change strikes. And we also have a lot of great great Bristol festivals which take place each summer to celebrate culture, diversity and art across the city. So this makes it a really exciting place for you to live as a student and as a professional, should you choose to stay living in Bristol after continuing your degree with us. Okay, and then I'm just going to touch briefly on the entry requirements. So to start with, if you are an undergraduate student looking to come to study engineering with us, if you are taking the Lise Diplomacy and the Fen Lisesi, we will accept your grades for direct entry. Any other Turkish curriculums, we will require you to take a foundation year. So the typical requirement for these is 65%. If you're unsure about this, feel free to get in touch and we can look into your curriculum and see whether we would accept it. So we are looking for about 80 to 85% overall in your years 11 and 12, with your science subjects at very high grades. And then we also need proof of your English language. So this can be done by an IELTS test. We also accept IGCSEs, your IB scores, or AP tests. There are also many different ways at the moment that you can sort of enter into our courses. So we are being more flexible with our English language, with home tests, and the IELTS indicator test, which is a test which you can do online. So this does mean that it's becoming more and more easy to prove your English language skills with us as well. For postgraduate students, it is a bit more difficult because we look at things on a case-by-case basis, so it's harder to say this is exactly what we accept. However, we are looking for a good undergraduate degree from a highly ranked Turkish institution. Our GPAs, depending on the subject and depending on your institution, ranges from about 3.1 to 3.5. But you can also include your professional experience in some of our courses to help with your academic experience as well. So all of the information about entry requirements for postgraduate subjects can be found on the individual admission statement on each course page. So once again, if you have any inquiries about admissions for postgraduate study, please do get in touch with us directly. Okay, and then for research, we would be looking for a master's degree which had a thesis component with a GPA of at least 3.0. Okay. And then I'm going to hand over to Andrew now, who's going to introduce you to the University of Bristol Faculty of Engineering. Take it away.
Hi. All right. Thank you. Good afternoon, good evening, everybody. So my pleasure to talk to you a little bit about engineering and the opportunities that we have for you here. First, I thought I'd talk a bit about why you might want to study engineering if you're considering a bachelor's degree, and what motivates us, why is it a valuable thing to study. Then from that, I'll talk about our research priorities and our research degrees, maybe looking a long time ahead for you. Then our bachelor's degrees, our undergraduate degrees, a little bit about our postgraduate degrees, and finish off with some opportunities for you here in Bristol. Okay, so first one of those, why do we study engineering? What's the point of engineering? Well, engineers are great at solving society's needs. Almost anything will have had that is man-made will have had an engineer at the heart of it, whether that's designing it, researching it, building it, maintaining it. We're critical to those products. You can see this bridge here is a real icon for Bristol, made by an engineer called Brunel. In fact, so famous a university was named after him in London. 100 years old photo with this early aircraft there, and then more modern aircraft also made in Bristol. So those are examples from the aerospace sector of the progress, the very rapid progress made in engineering in flight, and central to Bristol. In the civil engineering world, for example, we've gone from thousands of years of making sort of old bridges like this, quite small, very sturdy, to these ones which look more like a spider's web and are, vastly bigger, maybe 100 times bigger in scale. And that change in scale gives us new challenges, new problems. We couldn't simply make a stone bridge 100 times as big. We need to use new materials, new problems, and so on. Other examples, this could have been built any time in the past few thousand years. This Eiffel Tower in France is more recent, and this, you may recognize, it's about 900 meters tall. The weather is different up here to down at sea level. It's an extraordinary structure. And again, new civil engineering challenges to create these life-changing engineering products. We also have to get it right. Earthquakes can occur in many places in the world. They don't distinguish between rich and poor. They're just down to where you live. And when engineers get it wrong, or when there's a strong earthquake, there are disasters. So engineering is not it's not just deciding which piece of poetry is beautiful. If we get it right, we improve the quality of people's lives immeasurably. If we get it wrong, there's a tragedy. I've shown some earthquake areas perhaps relevant to us today. We're in Bristol, there's none that you can measure. Other parts of the world are not so fortunate. So that's an example of, again, the role of engineers. What about drinking water or water for agriculture and for industry? It's engineers that will provide the physical infrastructure that makes this possible. We tend to forget about water. We just turn the tap on and out it comes. But that really is a miracle that's been created over the last 100 or 150 years that we get to enjoy. And civil engineers will be at the heart of that. Other types of technology to enable people to fulfill their potential to overcome other barriers. Just an example from sports engineering here. Look at the world of, this looks like aerospace engineering. I was hoping to talk about Elon Musk's rocket launch, which was due to take place on Wednesday, but will now take place tomorrow, taking some American astronauts up into space. But however, what I want to talk about here, not just the aerospace side, but think of the electronics behind this and the purpose of many of these rockets, which is for exploration, to put satellites into space, and for telecommunications. Engineers have given this great improvement in quality of life to the world, in some ways through a huge use of energy. As we know, we need to move away from burning fossil fuels to renewable or sustainable forms of energy. So this can be through things like this enormous solar power plant here, or smaller scale ones here, offshore wind turbines replacing eventually gas and oil creation. Okay. Other things engineers can do through virtual reality and so on is improve our design of products, to develop them more rapidly and to make them more suited to what the customers will want. So this kind of visualization of products, unimaginable previously. Another, nice to have, folding up phone, some artificial limbs, so as a summary, really, we as engineers are able to really transform the quality of human life, to make life more interesting, give us more leisure time, less physically tiring, and spreading wealth around. And those our thirst to achieve that has created that shapes what we do in our research and in our teaching. And we have these research priorities, which also spread through our teaching. So first of all, composite materials, carbon fiber, glass, lighter, stronger. Security, digital security, cryptography, digital health. I won't go through all of these in any depth, but they really do spread right across human endeavour, and part of what makes Bristol such an interesting place to learn and to carry out research. And we also have for PhDs, for research, 7 centres of doctoral training, more than any other engineering faculty in the UK. And these provide a particularly well-supported way for you to do your PhD if you're interested in that in future years. Strongly integrated in with other universities and with industry. Bristol is a real hub for not just the aviation sector, but also other creative technologies, such as computer animation, design in silicon, and mechanical engineering, civil engineering manufacturers. I just described the faculty a little bit. So the Faculty of Engineering is one part of the university. The engineering faculty has nearly 500 academic staff, a large research grant portfolio, and as we mentioned, strong rankings, split into 2 schools, one with civil aerospace mechanical engineering called Kane, another one called SCHEME, where we have computer science, electrical engineering, electronic engineering, engineering mathematics. And these are 2 modern, well-facilitated buildings for us. Our degrees, if I talk about our undergrad degrees, first of all, they can be 3 years or 4 years. You can spend a year abroad, maybe in Europe, in America, in Australia, or stay in Bristol. You can spend a year in industry working with some of our industrial partners as a way of getting some income, but also some really valuable engineering experience as part of your degree. We'll teach you, well, partly online now, but through lectures, laboratories, tutorials, project work, and around 20 hours of contact time per week in a normal year. You will spend a similar amount of time studying on your own. Key to that, as you saw from our entry requirements, we need strong grades in mathematics and another science. Perhaps physics is an obvious one. We're fortunate to get very high quality students coming to us with these strong analytic skills. So we push that analysis side, that using mathematics, using science, using physics to explain engineering phenomena. That sounds quite dry, but as engineers, we take that science and we then use it to problem solve, through design of new structures, through laboratory work, through experimentation, new devices. We can give you a good blended education of the theoretical and the practical. It's a lot of work, but we will give you lots of support through that, and our degrees are all fully accredited. I'm not sure if this will play properly. So I'll just describe it. It's our shaking table. This is an earthquake simulator. I'll just see if it will do anything. This allows us to put large structures, in this case just little models that students have made, and to shake them around. I think the bandwidth is going to cause us a problem here. They will, you can see they're falling over. If the video was playing more quickly, you would see that in more real time. So this is an example of one of our laboratories. It's a research laboratory, but used for teaching purposes as well. And that's a world-class facility that we have. Perhaps more straightforward, I can show you. This is a kind of experimental rig perhaps you could make as a student. It's just a way of demonstrating. Oh, that's too slow as well, I'm afraid. It's basically solving the inverted pendulum problem. So how do you program a simple robot, in this case, to balance a pendulum upside down? There's a mathematical challenge there, but the more interesting challenge is actually the mechanics, the Newtonian mechanics, then the electronics, the software, etc., that we would expect you to make as an example of some student work. The reason for that, there's no particular value in balancing something upside down, except if you consider it's the same mathematics, the same principles, the same control techniques as for launching a rocket, where instead of a simple support at the bottom like this, the thrust is coming from the rockets. So the same mathematics is shown to work in both cases, hence that type of example. Let me move on, because I think these are going to be too slow. So if we have a quick look through some of the different subjects to study. So if it was aerospace, then this is a classic kind of syllabus, some flight dynamics, aeronautics, sensors, control, mathematics, etc. And you'll find those at other strong universities. What perhaps sets us apart is a variety of options for what you'd study in your fourth year, and a strong emphasis on project work. One little example here, some students have got a model of a bird and put it in a wind tunnel to try to understand its aerodynamics. How does it fly so efficiently? What can we learn from nature that we can incorporate into our own designs, for example? Another one here, some students had to design a little device to go in a small satellite sent into space to control the angle that it sits at, left, right, up, down, back to front, whatever. It's hard to do that when you've got nothing to hold on to. how do you make something turn around in space and point accurately in one direction or another, as you would need to do for a satellite. So they made a rig to do that, and there's some interesting mathematical engineering, design, creation issues there with that, which is another fun student project to do. If you looked at civil engineering, then we create the built environment. If you look around at those buildings, civil engineers, architects at the heart of those. And so their work lasts for decades. You can imagine that feeling of pride from looking at a bridge, a dam, a road, an airport, that you had a hand in designing, building, or maintaining, and doing it well is not only makes it a nicer product and a more appealing place to live or to work, but it will also make it function better, make it safer, stronger, and cheaper at the same time. We have within Bristol now a strong emphasis on the environment in our civil engineering courses, as well as design, problem solving. Mechanical engineering is our most popular of our bachelor's degrees in engineering, and it's very broad in its outlook. You learn many variety of skills there, prepare you for careers really across the engineering sector. That may be why it's so popular. Again, an emphasis as well as on the analysis, but on design, build, experiment, and test. COVID or not, you will still be doing laboratory work, practical work, and so on. You wouldn't want to be operated on by a doctor who just seen how to do it in lectures. Similarly, you wouldn't want to drive a car that had been designed just on a computer. You'd want the engineers to have done some practical work, some laboratory work there. So we have this mixture of analysis, design, build, test. And then a small degree, engineering mathematics. This is sort of halfway between an engineering degree with all those practical applications and a pure mathematics degree, which is hard and perhaps removed from the real world. Well, this is very applied engineering, applied mathematics. So how can we use mathematics to understand engineering better? And there are many areas where we're grateful to our colleagues in engineering mathematics for helping with those mathematical tasks. And our engineering mathematics graduates go on to many great careers afterwards. We have a joint mechanical plus electrical degree, another very general one. We could think of this as being focused on electrical energy management, which, strange phrase, but what we mean is as we move away from things like gas turbines, petrol engines, diesel engines as our prime movers, and towards electric motors, some of them very large, to decarbonize our energy use, then we need people who understand those mechanical and electronic side of things, and that's what this degree will train you to do. And there's a practical side as well as highly advanced analytics side. Electronic engineering, the electrical engineering side you can think of as power generation. Okay, which again we just assume we will have. You want to make some coffee, you plug your coffee machine in, and off it goes. The power comes straight out of the wall. But engineers are at the heart of that energy generation, and so electrical engineering role is there. Electronic engineering is looking at your mobile phone. There are chips, there are components at the heart of that. Electronic engineers will have designed those. We tend to notice the computer science. We notice the apps. How good are they? But they can't function without really high performance electronic engineering behind them. So that's those twin aspects of an electrical and electronic engineering degree. Computer science, this is taught within the engineering faculty, and we will teach you how to write a language, how to write a game, for example. What about databases, web technologies, cloud computing, cryptography, how do you send information securely, artificial intelligence, I hope that phrase means something to you. These are areas you can specialize in your third and fourth year. And I know our computer science students as well are in huge demand from industry. Now, as well as that just academic study, we also will help you through your degree to gain industrial experience, if you would like that, and to get a job at the end of it. And we have within the faculty our very own so-called industrial liaison office. So they link students with industry in a number of ways. One is that all of our first year students are given an industrialist, an engineer who's worked for maybe a few years, maybe for many years in industry. And they will come to meet you at the university a few times, maybe invite you to visit their company. They're good to talk to find out their experiences. What have they done well in their career? Where they will also tell you about mistakes they've made, for example. So it's a useful to have these mentors. They'll help you to arrange an internship over the summer between years of study, either in the UK or overseas. And we bring in other industrialists to give lectures on there, either as part of a degree course or just, as it were, for interest. So could be coming from Formula One racing team, or from Google, or from Huawei, or from Arup, a large civil engineering consultancy, maybe from Esso, Shell, BP, one of the oil giants. So again, those are other ways we will help you to think about your career and to launch a career successfully. As I mentioned, you can do a year in industry as part of your degree, and we will help you with that as well, as will the career service. Okay. We can show you lots of fine companies that our students have gone on to work for, and that list will change every year, but lots of strong companies. A little bit now about postgraduate degrees. So 1 year taught masters that we offer, some in the area of composite materials, so carbon fiber, glass fiber, used in the aerospace sector, so can be so much lighter and stronger than aluminium or steel, and hence widely used. And we have the UK's National Research Centre in Composite Materials at Bristol. Earthquake engineering, we have Europe's perhaps best, one of the very best earthquake research facilities in Europe, in Bristol, and we can teach you about how to design structures that will withstand an earthquake and a highly applicable degree. Another one on water and environmental management. So we can think of 3 sides to that. First of all, supplying clean water and taking it away when you've used it. Secondly, defense against climate change, particularly whether rising sea levels or increased damage from more violent weather. And thirdly, how do we reduce mankind's environmental impact where we and the water interface. Then another degree, engineering with management. We know that for engineers to be successful, what will get you that job in the first place will be your engineering excellence, your understanding of technology, of engineering science. But for your career to continue to flourish, you will need to understand something about management of people, of projects, of uncertainty, of risk. And so we will teach you about those as well as part of this engineering with management degree. And I'll just flick through a few photos for those for now, because I think we should move on. Within the other school, have a very, you can look through these later, but have a very wide range of MSc programs related to electronic engineering, computer science, engineering, mathematics, and I could pick on, well, any one of those. Perhaps this is an interesting one, computer science conversion course. If you've done maybe an engineering degree, a physics degree, a maths degree, a mechanical engineering degree, and you'd like to learn more about computer science, you can do a one-year conversion master's, and that will be very useful to you. Robotics masters we have as well, joint with another university. We have the largest, best equipped robotics laboratory in Europe by many measures, and it's a really exciting place to come and study for a year. So, a few other opportunities. We're sending up a CubeSat, little experiment in a box in a satellite to go and monitor volcanoes as part of some joint research, and there'll be lots of work with students over the next few years in that area. I mentioned the robotics laboratory, multidisciplinary robotic research. Come and study that. Lots of interest in those areas. We have a hack space, so you can use things like, well, we have our 3D printers you can see down here, but other electronics, mechanical production facilities to let you very rapidly develop your own ideas, design, build, test, see what works, what doesn't, collaborate with others, and many great ideas have come out of that space. They can be fun products, or they can be commercially viable products. So, just to summarise, then, come and join us. I hope we have world-leading researchers and educators. We work in a cross-disciplinary way. We don't see barriers between those different departments, and we're part of solving global problems. That's what makes us valuable. Our links with industry are exceptional. They will help you to build your CV, to build your future career. And don't forget the creative side of engineering, the ability to design, to build, to test. You don't get that in most other degrees. And that creativity is a nice thing to let go, to try out. And of course, as mentioned right at the start, it's a great city to come and study in. So we look forward to welcoming you in a few months. Okay, I think that's me done.
Yeah, so I'll take over from now. Thank you very much for presenting to us, Andrew. That was really interesting to hear all about the courses that are available for us and the curriculum. So I can't see any questions in the question box, so I will just move on to the rest of the presentation. Do keep asking the questions and we can answer them as and when. If you have any course-specific questions that Andrew will be able to answer for you, now is an amazing time because he can answer them live for you on the air. Okay, so on the screen, you can see a list of our official educational representatives. So these can be found on the website and you can find their contact details by clicking on them via the Turkey page. Okay, so you are not at an advantage by applying through a representative, but they will be able to help you with your application if you wish. Yeah, so the next slide, please. So I think this is quite a useful topic for everyone to hear about. We have some international scholarships available this year. Given the current situation, I recommend checking back next year just to see an update of how the scene has progressed. However, this year we were able to offer over £1 million of scholarships for 2020 entry for undergraduate and postgraduate students. So if you are looking to apply for 2020 entry, so this September, the application form is still open for postgraduate applications until the 14th of June. So I really recommend applying for these if you are still able to. And then for those of you who are looking into next year's entry, hopefully a similar sort of arrangement will be in place, but this will have to be confirmed on the website. This year we issued awards of £5,000, £10,000 at undergraduate level, and then the same at postgraduate level with a £20,000 bursary as well for tuition fees. These are. So I hope that's really useful to hear about. Next slide. Yeah, So here is my contact information. I have skipped short a bit, so maybe we could talk a bit more specifics about Andrew. Have you got any insight into your own individual research, which you're maybe currently undergoing, that might be interesting to hear? Have any exciting projects on the go?
Well, they're interesting to me. One area I could talk about, I'm taking some technology that one of my colleagues helped to develop for Formula One cars into road cars, in particular improving their suspension systems so that they're not going to go as fast as a Formula One car, but they can go around corners without falling over. And the motivation here is also to reduce the damage to roads. So some new technology that came. My colleague originally worked at the University of Cambridge. He joined us a few years ago. We're taking that development onwards. So that's one area. What else could I talk about? I think I'll leave it there for now. Yeah.
Great. So we've had a question through asking for a bit more specific information about the advanced microelectronic systems engineering. Do you have any sort of information about what that course content might look like?
So that's this one here, first one. There is, but the best way is, I think, is really to look on the engineering website. That will give you a full list of the different taught units, the content. So that, I know that sounds like a weak answer, but the trouble is, if I try to give you detailed information, I'll probably make some mistakes about it. What I would say is that you can imagine that now it's so easy for us to manufacture tiny little devices. They could be, say, like a tiny little pump that's just a few millimeters across, or a gyroscope, solid state gyroscope for measuring how quickly something is turning. And these can be made incredibly cheaply, and they can allow us to do all sorts of things that we simply couldn't do before. So your phone, for example, will have gyroscopes in it, which is how it knows when you turn it around. So there are this rapid development of taking things that were large, minimizing them typically in silicon, connecting them up to powerful processors that are also almost free now. It enables the growth, the creation of so many new products that were beyond what we could have imagined 30 or 40 years ago. And they can be used in not just in phones. For example, devices monitoring your health. My watch keeps telling me that I need to stand up and take some exercise and so on. It counts my footsteps, it measures my pulse rate. There will be things you can swallow which can measure your blood sugar level. There are so many applications of these microelectronic devices that have sensors, actuators, intelligence, and connection to the web.
Great, thanks for going into so much detail about that. That's really interesting to hear. I can't see any more questions to ask for you, Andrew. One of the students has asked about PhD study for applying for paid positions. Is that something that's offered within the faculty? I can't quite understand whether they mean as sort of undertaking research with a PhD student, or perhaps taking part in research with the professors that are already doing so, perhaps in the summer.
Yes, okay. So first of all, if you want to apply for a PhD, to study a PhD, if that's what you're asking, then as mentioned, there's do your bachelor's degree first, probably a master's degree as well. Come and talk to us. We have a lot of research money, which enables us to carry out a whole range of research projects, and so you can look through our research portfolio, look at the research group that you think will be of interest to you, and then contact whichever members of staff you think look like they're carrying out research in areas that are of interest to you. Make it an informal email is fine to do that. If you need to be paid to do it, just make that clear immediately, and then they can have a simple yes or no, and that may be the end of the conversation. If you are able to get a scholarship yourself, that will give you many more options, of course. Secondly, if you're coming to study with us as an undergraduate and you want to do some paid research work, then several of our staff will offer that in the summer vacation. They'll say, I've got this little package of research work which needs doing alongside some PhD students or postgraduate research, postdoctoral researchers, and we'll pay you to do that. So there are those opportunities. Not guaranteed, but there are those opportunities.
Great as well. They sound like a great way to spend your summer, especially considering with your Tier 4 study visa as an international student, you are eligible to work full-time outside of your studies during summer. So this means during the summer you could get a job, as Andrew mentioned, perhaps supervising some of the research within the faculty, or perhaps getting an internship at a local engineering firm. So there are a lot of businesses within Bristol which will be offering internships. You'll need to do a lot of this research yourself and find these connections to really see what you're interested in. But as Andrew mentioned, we have a really great industry liaison team and our careers services that are able to help you to find placements if you wish to do so. So one thing I thought would be quite interesting just to mention, we've got a few minutes left. So if anyone does have any last questions, do let us know. Andrew, could you go back to the slide with the picture of the buildings on? Maybe we could talk about the facilities that are inside the buildings on our campus. So our campus is located in the city centre of Bristol, and we have loads of different buildings all in the same vicinity in the city centre. So it's really great walking between your lectures. So Andrew, can you perhaps talk a little bit about the two buildings which are on the screen here?
Yeah, sure. Okay, so this one is called Queen's Building. It was opened by the Queen Elizabeth, in 1953, or no, something like that, a long time ago. And then she came back again in about 2008 to open some more laboratories. So this is where our aerospace, civil, mechanical engineering are. You really can't see the scale of it here. This is just one corner of it. But this is where we have many of our lecture theatres, but importantly our laboratories, our research laboratories, teaching laboratories. This more modern looking one is the computer science, electrical engineering, engineering maths one. In the background, one of our icons is the Wills Memorial Building, which is where, if you were studying law, you'd spend happy hours in there. We have other photos later on.
Right at the end.
All right, guys, thank you so much, all of you. We have 2 minutes to go. Anything last minute you want to add?
So these are just a few pictures of our campus.
So that here is my office. You can see where I'm I think what you'd appreciate, these are all university buildings. We're in the heart of the city, in fact slightly on top of the hill. And it's a beautiful city. It's such a comfortable and pleasant place to live.
That's great. Thanks so much for showing us those. Really great. So thank you very much for talking through the engineering faculty with us for all of our students. We really hope you've enjoyed it. Our email address is found in the chat box. So you can either contact our international office inbox or contact us directly. My email address is just on the screen now, so feel free to get in touch if you have any more questions. Thank you very much for joining us today, and I hope you have a great weekend.
Thank you.
Bye. Bye.
Bye bye.